Hello, welcome to Ekidel, where we train future civil and structural engineer. My name is Justice Onwaka. I am your instructor. Today, I'll be showing you how to design a foundation using Protastructure 2022. Now, on today's video, I'll be showing you how to design a part foundation using the Prota 2022 version. Now, most of you might have been using this version of Prota to design for your part foundation, but there may be some settings which you are missing, which I am to show you today what to do and how to get your part foundation design right on Protastructure 2022, which is not the same for how we design for part foundation for 2018 version. Okay, so right now you can see this building is a one-story residential building, and it is a real-life project basically. So I was about to design for the part foundation when I have to say, okay, let me use it to now show you guys how to design a part foundation. So I'm using the live project to design to make this video. Okay, so right now you can see before you must begin your foundation design, you must have gone through what they call interactive design and also perform your structural design of your structure. Now, if you look at this perfectly right now, you can see that I have done all my designs and I've checked all my members, the beam and the column. If you are a good follower of Ekidel, you must have heard me say most of the times that once you are done with your design using the software, you must have to perform what they call interactive design. It is like you, the engineer, checking the software. So you must check the beams, the columns, and all the members to make sure that the software is not giving you an excessive reinforcement or excessive depth and all that. So you must make sure you check all that. That is where you have the authority to check the software. So don't just depend on the software, else you will follow those people that says that software used to perform over design, which is not really right. The reason why this software Protastructure gives you the leverage for what they call interactive design, which is this area, is for you to check each of your members and to make sure that what the software gave you, for you to be able to make your own decision, where you can change your bar size or your bar number or your bar diameter. That's all. For right now, this is okay as 2 and as 2. So I make sure I check all my members before doing that. Okay. So once you're done checking all your members for that, then it's now time for us to now go and design for our substructure, which is basically the foundation. Okay. And also I have also told you guys how to choose your choice of foundation right. Okay. Because most of the times, most engineer finds it difficult to choose the type of foundation based on the structure and based on the bearing capacity. Because you know you don't only choose the type of foundation based on the bearing capacity. No, you only choose the type of foundation based on the number of stories. Okay, which I have said in most of my videos, and which we also teach on our Ekidel mentorship class. Okay, so right now I'll be showing you how to design for your part foundation right. But before I begin, I will say that if you are new to Ekidel and you have not subscribed to our channel Ekidel, I will say you should please do yourself this favor to subscribe so that you don't miss any of our amazing videos that we will be uploading soon and every time. Okay, and to all that have also subscribed, I'll say thank you so much. So right now, let's begin. Okay, so right now, to begin your foundation design, the first thing to do is to go back to your plan view on story 00. So make sure you make your plan view 00 active. Okay, so when you make your plan view 00 active, you will be left with only your columns because this is the substructure area. Okay, now since we have chosen to design for part foundation, now what made me to choose a part foundation as a choice of foundation for this one-story building is because, one, it is a one-story building. That is one. Two, the bearing capacity of the soil is 150 millimeter. Sorry, 150 kilonewton per meter square. Okay, so right now you can now see that that is the best choice of foundation to choose, and also from the from the soil report, there is nothing like a let me say there is no thing like there is no settlement issue, and there is no also that the place is has a water logging. Okay, so right now I will now have to go back to my plan view here, and on my plan view now, I will now begin to now design for my foundation. So since I'm using a path foundation, I will click on one of the columns here, and then right click here, and then go here and then say insert path base. Meanwhile, I told you that I will show you how people do their path foundation wrongly using this version and how you are meant to do it. So if you just go directly what I just go now, by clicking on a column, which we do most at times on 2018, and then we will now begin to set input our members on that, then you are getting it right, because 2022 version has default values which they fix as default. You can now see that the depth is default if as 400 millimeter. Now if you go and want to change this depth to 300, you can see that it will not take it, because you can see that it will not take it, because it will always change by itself back to 400. That's because that is how this software is being programmed. The reason why they program this way is because they don't know the capacity of the user or how experienced that user is, or that engineer that is using the software is. So just to avoid collapse, because that is what most softwares are into now, to avoid collapse of the structure, they have to now put in a and like to put in a default values for most of the places where you're going to key in. So it is now your right as the design engineer to go ahead and go and alter that default values which they gave you as a constant value. Okay, so right now you can see that what this software 2022 version gave us as a depth of our footing as default is 400. Even if I want to change now to 200, it will not work, or 250, it will not work. 250, it will not work. You can see that, sorry, 250, it won't work, sorry. 300, sorry, it's going back to, okay, then 250, it will not work. Can you see that? So it will always bring you back to 400, which is the default. Okay, so right now, don't just go ahead and go and use the 400 as the depth, because what happens is that you will now perform what they call over design, and you waste the client's money. And the main aim of every good civil engineer is to make sure that the structure is stable, and also to make sure that you don't waste much material. So your structure, while you focus on stability, also focus on the economic value or of that structure. Okay. So right now, I will have to now go and show you how to alter all these changes. And that is what you're going to do right now. So just close it up. So next time when you are trying to perform a path foundation, don't just go ahead and then click on the column and then go and say insert path base. No, you get it right. Sorry, wrong. Okay. So the first thing to do is to go and then go here that says settings here. Click on setting centers here and wait for it to display the setting center. Now, as it displays here, click on foundation here. As you can see that it shows you every other things here. So just go ahead and click on foundation, because we want to alter that stuff. Okay. So you alter foundation here, click on foundation here, and then on this place now, you have to impute your allowable soil strength, which simply means the bearing capacity of the soil. Basically, in 2018, you have to impute it while you're doing your design on the, you have to impute your soil bearing capacity on this area here. You can see that this is where 2018 shows the bearing capacity value for you to impute around here. Let me say material. Yes, around here. But on this version, I can see that they say ultimate soil stress of soil, which simply means the bearing capacity. I can see you're also showing now that it cannot be you can impute value here. Now, if you go here now and can impute value here by yourself, let me just say right now, since my own bearing capacity is 150, you will see that it will not work. That's because there is and even if I go ahead and then go and increase my sizes and all that. Come here now and increase my size here, square it and increase the size. You can see that? So I square again and increase the size. you can see that it is not also taking this square footing. Can you see that? Because there is a default value that it should always take a rectangular footing. And also the depth also is a default. So you must go and alter all these things. Okay, so right now, just go back and then go back to your settings center here. Now, once you go back to this place now, then go to this place here. Now, my bearing capacity based on this structure is 150. So I'm going to impute my bearing capacity here because on the other interface, it will have to multiply it by the factor of safety, which is 1.4 based on BS code for the factor of safety for foundation. Now, once it is being multiplied, it will now transfer the value of that net bearing capacity to you there, which you cannot be able to alter there. So make sure you come and put here your bearing capacity here. Okay, so I put now 150 as my bearing capacity. Leave this soil weight as default. That's okay. Leave this also, this surcharge coefficient as default. This value came from an average surcharge coefficient by the best soil mechanics professor, which is basically Joseph Boyce. And that is what most advanced softwares like Staadpro, Protastructure, ETABS, they use all that value. But if you want to now make your own choice, you can choose here and then go and click on select here and then choose your own. But I advise you always leave it as it is, except you understand how to choose your surcharge coefficient for lower limit and then upper limit. Now you can see that this software now is also referring you to the foundation analysis and design for Joseph Boyce. Now, our advice, if you want to know more about foundation design, go and read this book, Joseph Boyce. It is the best book in foundation design, and that is what most of the softwares uses for the foundation design. So if you want to know how these softwares behave for the case of foundation design, I would say that you should go and read this book. It is very, very good. Like every engineer that want to desire good future in this career must have read this book. Okay, so right now I'll just go and say cancel and then leave it as the default average value that was given by the professor Joseph Boyce. Okay, so right now on this place, once you input your bearing capacity now, here right now you have to now come here, which is the link concrete. You can choose to use it as 100, but link concrete simply means blinding. And here, based on your country or based on the place, but here in Nigeria, we use 50. So I'll put here 50 as my link concrete thickness. Although in US uses 100 most of the times. If you're designing with an US code, which is ACI, you have to use 100. But BS code and Eurocode uses 50 as their minimum link concrete or as a minimum blinding thickness. Okay. Now on this place here now, which says step footing, just leave this place as this default. Basically, this one is used when you're designing for a wide strip foundation. That's why you can make use of this left cantilever length and all that. Okay. So right now you can now see that at default, part footing is set as rectangle, which for me it is not right. It's not good for that. So always come here and choose what? Square. Change it to square so that you can be having a square footing most often, except you want to change to a rectangular, which you can do there. But for now, just choose square, not rectangle. Okay. Now, once you have done that now, the next thing to do right now is to now go over to this place that says design here. Now, on this design place here, this place now is giving you minimum footing width as 1000. That's fine. Leave it as it is. Although, yeah, that's fine. Just leave it as it is. I'll give you that advice. Leave it as it is. Now, on this place now that says minimum part depth, you can now see that it is given as 400, which is way not okay. Because from my experience, the minimum footing depth or part base depth, for me, I use this 300. But most people use this 250. So right now, I'll just go, and most people also use 200. That's based on how the terrain of that area is. All right. So right now, I'm going to use 300 as my minimum, or I'll just use 250 as my minimum, okay? 250 or 200 as my minimum. Sorry, 200 minimum, okay? Most people use 200, 250, and 300, but me, I like to use 300. But just for the sake of other people's choice, I just use 200, but I'm not using 200 for my design, but this is just the minimum. That is what is there, okay? Then on this place now that says maximum steel bar spacing, leave it as 250. Although most people use this 300, but not for foundation, for slabs and all that, for beams. But for foundation, leave it as 250. Now, for this place that says size increment steps, most people, I don't like to use 100. Most software uses 100, but I like to use 50 as my increment. What this means is that if my pad footing now is meant to be 1 meter by 1 meter or 2 meter by 2 meter. Now, if at 1 meter there is a failure of the foundation, let me say the size was not sufficient. If you want to increase, instead of it to just increase to 1.1, let it try 1.050. Or let me say if your footing is 2 meter from your design and that footing is failing and you want to increase the size of the footing, instead of it to increase by 2.1, let it go ahead to at least try 2.050. You can see that. That's how it is. So I'll use 50 here. You can choose to use here 100 or 100. That's your own choice. But me, I like to use 50, which is, I like to be very, very economical when I'm doing my design, because I put my client also into consideration. Because if your design is very perfect and suitable, but the cost of constructing that design or that building or that structure is very, very expensive, that makes you not a good engineer, right? And these things I'm telling you will help you when you're bidding for a contract. So make sure you use the barest minimum, except it is failing. Then you now have to increase a bit, and don't just go and increase to the highest. No, you waste the client's money. Make sure you just increase step by step, and to get the exact one which we fit in, which will be adequate to carry that load. All right, or yeah. Okay, so right now on this place now that says cover, for foundation, it is, you can use minimum of 40 or 50. Why US ACI uses 75 and 100 as their cover of concrete for foundation. So right now the software gave me 40 as 40, which is the minimum, but right now I'm going to use 50 because 50 is the most common, and it will be very, very easy to measure 50 at site for like when you're using the tape. So that's why I'm using 50 millimeter. Okay, so right now on this place now, let me just go here. Right now on this place now, for the steel bars, you can see that it is showing you here that use top bars. Top bars, if you check this as to use top bars for your pad base, what it means is that all your pad base foundation will be doubly reinforced. But basically, most pad base footing are singly reinforced, except the size of this footing is very wide. Then you can now choose to use a doubly reinforced, which is the top and bottom reinforcement. Apart from that, it is good to use just the bottom reinforcement and not the top reinforcement. Now, another way again where you have to use a doubly reinforced is when you are designing for a combined footing. When you're combining two columns on one footing, then you have to use that design for the combined footing for doubly reinforced for every combined footing. That's because for a combined footing, there is a very high moment. There is a very hugging moment and very high moment, which you need a top reinforcement to be able to stop that stress that is happening on that combined footing. Okay, so but right now I'll have to remove my top bars, except except along the line we have to see a combined footing or a footing that is very wide, like let me say 2.5 or 3 meter by 3 meter, which is not really adequate to use that. Then you cannot choose to use a top bar for that. But for now, I say no. Okay. Then also on this page that says minimum steel bars, I think most of my video I've seen it most of the times that when you're designing for a pad foundation and for one-story building, carry in mind to use diameter 12. That is okay. 12 is okay to use that, and don't use 16. 16 can be used for a 2-story building, 3-story building, and 4-story building. Yeah, or when the even if it's a 1-story building and it's very, very large and has much life load and dead load and all that, has much design load, then you can be able to choose for 16. But even if you choose 12 and then it is now required to use 16, you will be seen along the line on the design, and you'll be seeing the warning that the steel is not sufficient. Then at that point, you cannot come and now choose 16, which you can still choose from that interface and not here. But for here, use your minimum as 12 so that in case there is any pad base or footing that is meant to carry 12 diameter of bar, instead of, but since there is no 12 and what was here was 16, it can use 16, which in turn you have done what they call over design, and that is bad. Okay, so right now, once you choose this right now and then come here and then click on OK, so you can now see how we have done the settings and then click on OK. So it is only on this right now you have done your perfect settings for your foundation. It is now that you can now begin to now design for your foundation, for your pad foundation. Okay, so right now just go here right now and then click on my column right now, right click and then say what? Insert pad footing. Okay, and then wait for it to show the dialog box out. Now once it shows up right now, you can now see that it is now showing us our default depth now has now become what? 250. That's what we set. So right now, and even at 250, it is still passing. I can see that everything is okay. If we go ahead and then say design, it is okay. But like I said, I like to use my minimum depth of footing as 300. That is based on my own experience. Most people use other lower one, but not lower than 200. Okay, so I'll use 300 now. Sorry, I'll use 300 now as my what? My footing depth, as you can see that, and then I'll just change here and say footing label. I'll just say here and say base type 1, base type 1, base type 1. Okay, and then again I'll have to now, you can see that now it is now showing our cover to reinforcement as 50. Leave this tapped height as what? 0, except you want to have a tapped foundation, which basically is no longer in use, except most of the buildings in Rome, Italy. You can see that basically this was used over 50 years ago in engineering, but we don't use that again right now, except you want to use that. Okay, but leave it as default. I advise that. Okay, so right on this place here right now, you can see that our length of footing and the width of our footing is what? 1250. Now had it been we didn't use 50 as our size increment, what would have happened? It would have given me 1.3 by 1.3, which, not knowing that 1250 can be able to carry the load coming from this column. Okay, so right now I'll just come here and check what? Square footing here. Okay, now once you have checked that, on this place that says pad footing eccentricity, I would advise you leave it as default most at times. It is only in a rare condition you can be able to choose at this place here. Now what happens when you add here is that when you add here, the column on the pad base will have to move from the center of the footing, which is very, very right to have that, to the left or right at the end of it. So let me just show you that right now. If I come here right now and add 500 and click anywhere here, you can now see how it happened here, which is basically very hard to design, and it might cause what they call tilting of the footing. So I advise you don't just do that, okay? Except you know how to design it very, very well, which I might do later for you guys. But for now, we are designing for 0 eccentricity, which is very, very perfect, okay? Now, you can, once you have done that just now, and then just go down here and check, make sure you check all your check-ins here, check everything here, and then once everything here is showing okay, that is not the only check-in you are going to do. Then you also come here right now, material here, leave pedestal. Pedestal, we are not designing for pedestal. Pedestal is basically for for steel structure, let me say if you have a steel stanchion and then you want to bolt, you want now bolt your steel stanchion to a pedestal. That's what you cannot design for a pedestal. I'll show you that later, but for now we are focusing on what pad foundation design for a one-story building. Okay, now move to material here. Now on the material here, you can see that this is our concrete grade which we use for our design. I can come here and choose concrete grade for foundation. Since this is foundation and it is always directly to the soil, I can choose to choose 20 or 25 as my concrete grade, or I can still use 25 concrete grade, and I'll just say what okay here. Okay, that's fine. It is good to use a high grade like 20-25 for a higher than 20 for your because this first one here is simply called a cylinder strength, and this one here is called a cube strength. And what we use for the design of structure is a cube strength. Cylinder strength is just for experimental value and all that. So we use a cube strength for our design. So basically right now I am using concrete grade of 25 for the design of this foundation. While for the superstructure I use grade what 20 for the members. Okay, now once you do that right now, leave your steel as it is 410. I've already said that before on most of my videos, and then come here right now for your bar diameter. You know, we have already choose Y12 as the minimum, but to still choose, if you want to choose other ones, come here right now, click here, and then you can now see that you have the right to choose trace yourself right now for this is footing, and this is the symbol of footing here. So come here along the footing here and then choose all the bars you want. I don't want diameter 20 for my footing here, so I'll just take minimum as 12 and maximum bar as 16 for my footing. Okay, and then come here and then say what okay, that's fine. So once you have done that, now you can now see that it has now done what it has just this is now our soil properties, which is now showing ultimate soil stress. What does this thing mean? This simply means ultimate soil stress, which means that remember that our bearing capacity was 150 kilonewton per meter square. Now this value here has been multiplied by the factor of safety of 1.4, which now gives us 210 kilonewton per meter square. That if we now multiply 150 multiplied by 1.4, that will give you this value, which is now the ultimate stress of soil. Now if you also go below down here, you can now see that the net bearing capacity is given by 210 kilonewton per meter square, which is showing you also that the ultimate strength factor that was used to now get this value was 1.4, which is the factor of safety from BS code of practice. Okay, and then why if you are using Eurocode gives 1.25 as the factor of safety. Okay, so right now if you multiply this value by the bearing capacity which we have 150, you get this value here. Okay, now so you cannot see that you cannot, it is good for you to put your bearing capacity on that first stage and not on this place. Although you can still want to change it here, but I don't advise you to change it. You can choose to change it, but I don't advise, because when you change here, what you are doing is that what you're changing is the ultimate stress of soil and not the allowable stress of soil. Allowable stress of soil is the main bearing capacity that came from the soil reports. Okay, so always don't use that. Okay, so right now leave all this place here, which is the heat height as default. Leave this surcharge coefficient as it is, and then leave this one also as it is default. Now once you have done that right now, you can now go here and then check for options here. Now these options, now you can see that it is still showing here that link concrete is showing as what 100. So come here and then put what 50 as link concrete again. And then you can also want to change the depth increment here. If I come here, don't forget that here I was showing what our size was 250. If I come here now and say 100 here, 100 here, and then go again and say design now, you can now see that it's showing one by one, and also it is still failing. So I'll just go here right now and put to 50 and put to what 50 again, and then come here and then say design here. Okay, now if I come back here right now, that's why basically I don't have to change my settings here. Once I'm done to change my settings on the other side, I'll come here again right now, confirm again, it is failing. I come here right now and then send again, and then come, okay, here I put it to be 300, then come here and then increase this. So you square it again, square, increase to 1250, and also here again, 1250. Okay, so you can see that this is now perfect here. So this is 150 is the exact size that that is able to carry the load here. Okay, and then I'll come here right now for the column load here to see the column load out. Let me go back again, option here. So these are all the things I'm going to choose. Leave this other one here. Don't apply this. Okay, and then come here and then go to this column load here. Now column load, now you will see the column or the combination that was used to now take the highest axial load that was used to size and to design for this footing that was coming from the column. Okay, so right now on the rebar here, now you can see that on the rebar here, this one that is showing rebar X and rebar Y is basically your what? Your bottom bars. Bottom bars on X direction and bottom bars on Y direction. Now, for you to now understand this place very well, I'll have to show you a 3D reinforcement, because this version of Flutter gives options for that. Okay, so I'll come here right now and say 3D reinforcement here and wait for it to show. Okay, so once it shows like this right now, just try to move your mouse by try to hold your down key and then move your mouse up and down, and then you will see this thing very clearly as it is here. Now basically, let me just rotate it so I can be able to see it perfectly. Okay, so basically now I cannot see that basically if you go and check for these two, which is at default, this is checked, top bars are checked at default. This is what you're going to have. You have your reinforcement like this, which this one that is yellow and that is sign here is called the bottom bar at both direction, and the green and the blue here is called the top bar, which basically we don't need this for this footing, except your footing is very wide, like 3 meter by 3 meter and all that, and then you can be able to use a double footing like to be able to carry or withstand that moment. Okay, or when you have a combined footing. I've seen that before. So right now we don't need this top bar here, so just come here and check the top bars. We don't need that. We only need the bottom bars. Okay, now I can see our bottom bar here right now. Now I can see that the bottom bar here from our design here, it is showing us that we have 5 numbers of diameter what 16 at 250 spacing, and at X direction, which is vertical direction, and also 5 again. So if you check now and count this yellow one here, we have 1 2 3 4 5, and the green also 1 2 3 4 5. So you can see that right now. Now if I still want to choose use diameter 12, let me check if that will be okay for that, and then come here again and choose again 12 diameter. Okay, the design is still okay and perfect. And then come here right now, you can see that the size have increased, have a decrease. And if I come here, if I want to change my spacing, now from 250 to, let me say 200 and 200, what will happen is that it will have an impact on the number of the reinforcement for the base required. Okay, so you can see that we now have 7 numbers. As you can see that it has increased compared to what we have before as 5, which was adequate. So right now I'll just go ahead right now and then say what 250 as my spacing of reinforcement, and also here to 250 also. Okay, so that takes us back right now to what they call as our 5 here, 5 bars on both directions, X and Y direction. So there is also where they add distribution bars like this. But basically, for this to add, you must to add the top bars first for you to be able to add distribution bars. Then add the bulb, which is the anchor for the top, and then add distribution bars now. Come here, you show -1, click it off. Okay. Okay, basically we didn't check this one yet, but we don't use these distribution bars except when your footing is very, very deep. When your footing is deep up to 600 millimeter depth, when this depth here is 600 and above or 500, then you will have to add these two bars here called distribution bars. Apart from that, don't add it up. Okay, so just uncheck that distribution bars and uncheck your uncheck this your top bars. Okay, so right now you can now see this is how our footing is meant to look. So you can now see how we have designed this part foundation perfectly, and everything looks okay. And all our check-ins for the punching, you can see that the punching check at the control perimeter is okay, which is 524 greater than the minimum. Can you see that? And also for the shear failure, for the shear at the face, you can see that we have 312.6 above, which is already more than 117.3, which is the minimum. So you can see that all our check-ins are okay and design is okay. So right now, I will now come here and then say final okay here and then say okay here. Okay, that's fine. So on this place now, you now wait for it to now insert the pad footing. So you can now see how we designed perfectly this part foundation, and it's showing base type 1. So with the same step, right, let me just do for the last one, then we just use the same step to now design for all of them. So I'll go again right now and then design for this again here. Okay, design for this again here. And wait for it to show the dialog box. Okay. Okay, so once that dialog box comes up right now, okay, and then we now go again right now and put our pad depth 300, okay, and then come here and click on square footing, and then come again and confirm that everything is okay for the punching and everything, and then everything here is showing design is successful, and then come here, material, leave material alone because everything is already okay. Come here, options, and then rebars. Basically, once you're done with your geometry here and everything looks okay, come to rebars here and then confirm your bar diameter. You can see that it's using 16, which is not okay. Now I'll go and try 12. If 12 is not sufficient, then I'll go and use 16. Okay, so 12 is sufficient here. So now you can now see why you must check your check the software before it gave us what 16 as the bar diameter, why 12 was sufficient for that. So I'll come here again right now and uncheck this. So if I come here and check these two values now, show my 3D view, that is if you want to put top bar, but it's not good to put top bar, show the top bar. Now to now show the other bars for distribution, if I check these two right now and come here, sorry, come here first and put, let me just put 3 here and then 3 here. Okay, basically this ones that is saying distribution here is not majorly required for a shallow foundation for when the depth is shallow, but when the depth is not shallow, let me say if you're designing for a higher depth, then I'll show you how to add these bars of what distribution. Basically, they are being found at the edges of the footing. That is to be able to support the top bar and the bottom bar at the edge, and basically it is acting against shear. It is also it will also help against shear failure. Okay, so right now just remove this top bar because we are not doing for a combined for a double reinforce. Okay, so right now you can now see our design here for the pad foundation here. Okay, that's fine. So right now everything is okay again. I'll now come here and then say what again? I'll say okay here. Okay, that's fine. So let me go and change this right now to, since I have here, I have my 1250 as my B type 1. I'll come here and change this to what? B type 2. I'll come here right now, properties, and then come here. Since it's a different size, I'll come here and choose B base type, then 2, and say what? And then come here and then say okay here. That's fine. Okay. So it will change right now to base type 2, as you can see it here. Okay, so so if you can check our 3D view right now, you will see that we have successfully done these first two pad foundation here, which you're seeing here. As you can see it here right now, we have done these first two footings here. Okay, now if I want to change the color of my members right now, I'll quickly go to here, then go to display, go back to view, sorry, display here, then go to layer here, and then go to layer settings here, and then wait for it to show the dialog box. Now I want to change the color of my members for beams, color, and all that. I love to change those members because I don't like this default color that the software gave me. Okay, so basically that's how to design for a pad foundation. Okay, so right now go right now and then choose my column. I like to use my column to be I'll choose this color of my column. Let me just choose this color here. Let me choose here. This is okay. I'll come and choose my beams, my beam color, which is the hash, to be what? Green. I like to use deep green. Then my slab, I like to use this other one here that is darker. And then for my wall load, partition wall load, I like to use this same one here, but I will not go and increase this opacity for it to be thicker. Then I'll go back to my slab now. Back to my slab now. Back to my slab. Then footing, sorry, footing, which is foundation footing. Yes, footing. Come here, and I'll choose let me choose this, okay, for my footing. And then come here and increase the opacity for it to not to be transparent. Okay. Then come again now. Come again, sorry. Go and choose my go to back to my slab. By slab here, and then choose out. Let me choose this other one here. That is yes, this other one. And then come here right now, and then make sure you say okay once you're done changing your colors, and then say what? Okay here. That's fine. Then wait for it to not change. Okay, that's perfect. You can now see that we have not changed the color of this. Now to hide this, our grid line here, I can choose to hide my grid line by just coming here and then hide this. Just click on this place that says axis. Okay, it will hide these grid lines. Just turn them off. Okay, that's fine. So you can now see this is now our first footing that we did, and second one here. So with this idea just now, I will not perform for all the other footing. So with this idea, I'll repeat for other footing and then come back to the video. Okay, that's fine. Okay, so basically now we have seen that I have just done all the design for the pad footing, following the same step which I used to like design for these two footings as you have seen before. So if I now go back right now to my 3D view here, 3D view, you will now be able to see that we have just done the foundation design for these other ones here, as you can see that right now. Let me just go here and then turn on my go back to my layer here and just say okay for it to show back the footing. Okay, that's fine. So you can see that we have now done our footing design perfectly here. You can see that right now. And then also you can also see that we have also okay, let me go and turn on my grid line now back, okay, as it is. Okay, that's fine. So you can now see that we have just done our design perfectly, although I like to turn off my grid line here and turn it off. So this is how to design for a pad footing. So following the steps which I just showed you right now, you can design a pad foundation perfectly for any kind of structure, depending it is lower than it is no more than 4-story building. Okay, most people used to use pad foundation for a 5-story building. Well, it's fine, but for me, I don't like using it. Although if I'm going to use it, I'll still use a ground beam to connect all the columns together. That will give a good stability. Okay. So right now, you can now see what we have done so far. Now, if you have not yet subscribed to our channel and you have watched up to this extent, I'll say you please just pause the video right now and then click on the subscribe button so that you don't miss our amazing video for other type of foundation. And to you that have subscribed, I say thank you so much and God bless you. Also recommend your friends if you're a student, and also recommend your colleagues if you're working in the office, so that they will also have the knowledge on how to design structures Try to spread the knowledge. Don't be stingy for knowledge, and God bless you, and they will love you. Now, if you have any questions so far, I would say you should drop the question down on the comment section. And we have also provided a WhatsApp group link, which is also on this video description below. And then on my next video, I'll be showing you how to export your structural details after you're done to design to AutoCAD from this version of 2022 Protastructure, and then you also see how to do that. Most of you are having difficulties in doing that, but I'll be showing you the simpler way to do that on my next video. So stay tuned, and then God bless you, and they will love you. Goodbye for now, and then bye.